Alright, good morning. Back for some more Advent of Code. This is day 15. Chiton. Okay, so this sounds like shortest path. Finally, I might need that cue. You've almost reached the exit of the cave, but the walls are getting closer together. Your submarine can barely still fit, though. The main problem is that the walls of the cave are covered in chitons, and it would be best not to bump any of them. The cavern is large but has a very low ceiling, restricting your motion to 2 dimensions. The shape of the cavern resembles a square. A quick scan of chiton density produces a map of risk level throughout the cave, your puzzle input. For example, you start in the top left position, your destination is the bottom right position, and you cannot move diagonally. The number at each position is its risk level. To determine the total risk of an entire path, add up the risk levels of each position you enter. That is, don't count the risk level of your starting position, okay? And don't count the risk level of your starting position unless you enter it. Why would I enter it? Your goal is to find a path with the lowest total risk. Well, it seems that I will never enter the starting position, because any path, well, if I start at my starting position and go anywhere and come back to my starting position, it seems that whatever path I go through from there will have lower risk if I don't do the silly loop at the start. Oh, 100 by 100, isn't it? Well, the obvious way to do this is with Dijkstra's algorithm. Unfortunately, I don't have anything that I could sensibly use as a priority queue. So I'm wondering if it's better to figure out how to make a priority queue on my own, go and read up on how to make a priority queue, or try to come up with some funny hacks to do it without a priority queue. And I rather favour this option. But let's get the input read first. Oh, how did I read in a grid the other day? Last night I made a multi-dimensional array allocation function. So we want to so that gives us the width and the height. And then we'll just print them out just to make sure we've read it incorrectly. Okay, good. We're reading in the input correctly. Now then, what weird hacks are we going to do? I'm thinking something along the lines of, we use a growable array as if it was a queue, and whenever we have a new point to add to the queue, we just stick it at the end, and every 100 iterations or so, we sort the array by priority. And when we find a route to the destination, we don't know if that's the shortest route to the destination until the next time we sort the array and the first thing in the queue has a higher path length than the best path length we've found so far. Now obviously that is worse computational complexity than something with a proper priority queue. But do you have any better ideas? So another option is that we have 9 separate queues, and whenever we visit a point, well, we choose which queue to put it on. Okay, I'm just going to try the thing I said about sorting the queue every so often. So
I'll have a go in here for that.
So the fourth element will tell us if it's already been popped off. And when it goes to 100, what we want to do is sort so that low risk is first, already popped is last, and then truncate at Q size. So then we'll GR trunk Q size. Is that off by 1 on Q size? Let's see what GR trunk does. It sets the length to be whatever you say. So yeah, that's correct. So now we want to sort. So if B has already been popped off, then we want A to come first. If A has already been popped off, we want B to come first. If they both already been popped off, we don't care because we're going to truncate them both off. Otherwise, they're both still members, so we want A to come first if it has lower risk than B. So we want it to be A2 minus B2. Actually, I've just had a much better idea than this Q thing. Since we're reading the grid into memory, why don't we just say that we just iterate along the grid and say that the shortest path to a given point is equal to the current cost of that point plus the minimum of up and left, because a path might go like this. Okay, well, we'll stick with this for now. It feels like that might be better. Yeah, I'm going to say that's better. So what I'm going to do, so we might have to do several iterations over the grid, but that'll be okay. What I'm going to do is copy part1.sl, part1q.sl, because if that Q thing actually turns out to be useful, then I want it. But we'll throw that away now. So what we want to do instead is we want a second grid. So that's the grid of costs. We also want a grid of like total risk. Let's call it risk. And this wants to be height by width. So now the risk at point y x let's just go update xy. if the risk at this point is unknown,
then it just comes from the grid.
we don't need that actually. So the value from the grid is grid yx, and then risk yx equals g. And if x is greater than 0, then g is g plus risk yx minus 1. If y is greater than 0, gy is g plus risk y minus 1x. So, okay, that'll be good. And then, okay, and only if risk yx, only if risk yx equals 0, or g is less than risk yx, do we assign to it. Okay. So, having looped over the grid, best path is risk yx. If best path is less than last best path, then last best path is best path, and we want to loop again. Otherwise, the path isn't getting shorter anymore, so we simply print the best path and exit. So let's try that. Actually, what I'll do is I'll print the path length every loop, so we can see what's going on. That doesn't want to be yx, does it? That wants to be height minus 1, width minus 1. And I don't think the path can be a big int, because in the worst case, every single point on the grid is a 9, so we have to go 100 across and 100 down of 9s, which adds up to 200 times 9, 1800. So the path is going to be less than 1800. Was 518 the answer? Suspicious that it got it on the first try, if so. 40. Oh, also, if x is less than width and risk yx plus 1, and if y is less than height and risk y plus 1x is known, and this is less than gy, and gy is risk y plus 1x. I don't understand where 518 comes from. Wow, okay. That should be G plus, that. VZ malloc 0 is your memory. What the hell? Yeah, so where does that come from? 518 is bigger than it can possibly be, isn't it? Is that just the sum of every element in the table? I think it might be. $147. Oh, I'm adding up ASCII characters. Ugh. Maybe it would have been worth doing the thing where I surround the grid with elements of maximum cost, so that I don't have to do all this bounds checking on the coordinates. So what is the ASCII value for 1? That's 0x31, which is 33. That still doesn't completely make sense. Oh no, 3 times 16, so it's 49. Yeah, 3 49s is 147. But, oh no, you don't count the top left one because you're not stepping onto it. I still think that's wrong. Oops. Three. So why does it think the path length is 3? It should be 4. Well, I was just going to say if x equals 0 and y equals 0, then the risk yx equals 0. But I'm using 0 to indicate unknown cost. What we'll do is we'll just subtract off at the end the cost of the top left square. And then the other thing is, why is it coming up with 3 instead of 5? so that's coming up with 31 instead of 40. Uh, $21, what's that then? It's not subtracting off the 0. Oh, I didn't recompile it. Interesting. I think that might be the problem again, where sometimes I end up with a binary that crashes rather than working even when the source is correct. So that hasn't even read in the input, and it crashes every time. So this might suggest, assuming I didn't just write some stupid bug and not realise, this seems to suggest that the problem wasn't the compact flash card, because I've got a new compact flash card in now. Yeah, and I recompiled it and now it doesn't crash anymore. I'm really interested to take a look at that binary later. So that looks like the path it's going is 11149, or 1149 rather. Oh, hang on, does that look correct? So why is that a shorter path? That's the same grid but transposed. I feel like I'm probably just looking at the wrong coordinates somewhere. Well, we always know that when we update x, y, we've done all the points with x lower than this x on the same y, and we've done all the points at all with y lower than this y on any x. I should have taken a copy of a good binary as well, shouldn't I? If I stop this now, too late. Damn. Part 1 just after bad binary. At least I'll be able to watch back the video and work out what changes I made. So I should be able to reproduce the good binary. Right, let's try and work this out then. Cost to get to 0, 0 is 1, because it's a 1. The cost to get to 1, 0 is 2. Oh, that's correct. The cost to get to 0, 0 is 1 is correct. Cost to get to 0, 1 is 1 is correct. No, it's not correct. Cost to get to 0, 1 should be 2. So we're basically allowing ourselves to travel down y for free. But a y. Because I put an x there, and I should. Yeah, so we were on the first column, we were allowed to travel down for free, because if there was no gx set, then we'd always use the gy value as if it was the whole thing. Oh, sorry, no, that's not what it is. If there's no gx set, then gx is some uninitialized value, so g never gets assigned either gx or gy, so at the end we set risk yx equals g, which is just the initial thing of grid yx. Forgot about that. 30, no, incorrect. Oh. Yeah, that's still wrong, because gy isn't going to be less than g. Okay, so we won't take a gy and a gx. What we'll do is we'll only set
risk. Or was that really high?
so if y is greater than 0 and g plus risk
Y minus 1x is less than the risk, then we'll use it.
but if yeah, so the reason I had all that stuff was to handle the top left position, wasn't it? Good. Let's get rid of the spam then. Maybe this is going to be too slow. Maybe I would have been better off with the queue. That'd be annoying, wouldn't it? I would have expected it to take more than one pass. Interesting. Let's get part 2 then. Why did that work in one pass? Because surely if the path has to come back up, I wonder if the original problem statement said you can only go right and down and you can't go up or left. Didn't say that. Right, what's the second part then? Now that you know how to find low-risk paths in the cave, you can try to find your way out. The entire cave is actually 5 times larger in both directions than you thought. The area you originally scanned is just one tile in a 5x5 tile area that forms the full map. Your original map tile repeats to the right and downward. Each time the tile repeats to the right or downward, all of its risk levels are 1 higher than the tile immediately up or left of it. However, risk levels above 9 wrap back around to 1. So if your original map had some position with a risk level of 8, then the same position on each of the 25 total tiles. Okay, yeah, I understand. So I don't have enough memory to store 25 copies of my grid. So what are we going to do about that? Maybe this time we actually do have to do the queue thing. Obviously I don't need to store 25 copies of the input grid because I can derive the risk of every position knowing just the one grid. But the way I've written part 1, I would need to store 25 copies worth of my risk array because that tells me the shortest path to any position. What if we just calculated the shortest path to every position on the perimeter of the first tile, and then for the next tile we look at the shortest path from any point on this perimeter to any point elsewhere on the perimeter, and then we only need to store 1 at a time. I'm going to give it some silent contemplation. Someone at the door. Well, I think we'll try the queue thing. I bet you can't wait to see me struggle to implement this. I'm not going to upload part 2 because I haven't done it yet. It's taken a long time. But what's happened so far is I've started again on the version using the queue, implemented it all the way, and tried to run it, and it runs out of memory on the sample input, which isn't a good sign. So, don't know exactly what I'm going to do for part 2, but it's probably going to be strange enough that it's not to be filmed. Anyway, thanks for watching. Goodbye.